Good, we are live. It's gonna work. I like that. Okay, today is Pi Day. It really is. I know. And normally, if you've been with me, we normally do Pi Day and we bring pie in it. But with the new school, they don't want any, and it always creates a big mess in my classroom. It does. So then I thought we'd go downstairs. And when downstairs, they said, no, you can't do it down here because the janitor needs to get ready for lunch. Okay, anyway, it is 3/14, right? That's why it's Pi Day, because it's 3/14. So if you never knew that, it's March 14th, it's 3/14. That's why it's Pi Day. If you didn't know that, hello, you just learned something, right? March 14th, that's why it's called Pi Day, okay? Now, if you just learned something, awesome, yes.
Back in 2015, it was great.
Super Pi Day, wasn't it?
Yeah.
Yeah. Because back...
2059, that's the year that's the best day.
Right. Okay, here we go. So, composite functions. So we're going to add, subtract, multiply, divide, and we're going to put a function into a function, okay? Composite function is like add, subtract, multiply, divide, add, subtract, multiply, divide, and, believe it or not, we're going to put a function into a function. Function into a function. And that's the new part. Sorry, it's so sloppy, you guys. We're going to put a function into a function. Sorry, so sloppy. All right, so part of it is what they're asking, and it's actually pretty easy, but some books like to write this in this really weird form. So it really is just saying this. It really is saying take f of x plus g of x, but it's just written in an odd way. Same thing. So don't let the symbolism bother you, and I think unfortunately sometimes in math, we take a really easy concept and we put math language to it and nobody has a clue what they're asking. You've seen that, haven't you, okay? So they're just really saying add them. So if I'm going to take f of x and add it to g of x, I'm just going to take my 2x minus 2 and add it to my x squared minus 2x plus 1. That's all I'm doing is adding my functions. So if I'm going to add my functions, I'm just going to add the things that are the same, right? X squared. It's the only x squared. You guys agree?
Yes.
2x, negative 2x? Cancel, right? Negative 2 plus 1 is, that's my answer. It's actually pretty easy, isn't it? We've done this. It's just a different way to look at it. That's why I said it's easy and not easy. Okay, and I'll show you the not easy coming up here in a little bit, but not yet, okay? So f minus g, what they're saying is just take f of x and subtract g of x. That's all we're going to do is subtract the function. So, all right, I can do that. I'll take my 2x minus 2 and I'm going to subtract. I've got to be careful when I subtract x squared minus 2x plus 1. I've got to subtract the entire function, okay? Subtracting the entire function, so you've got to be careful with the negatives, right? So I'm going to go, okay, if I bring the negative through, okay, for me, because I make mistakes, you've seen that. How many times I make mistakes? At least several times a day, right? So for me, I make dumb mistakes, not that you ever do, but I'm going to bring the negative through. 2x minus 2 minus x squared plus 2x minus 1, right? So I'm going to subtract the entire function, right? So if I subtract the entire function and bring the negative through, okay, so I'm going to have a negative x squared plus 4x minus 3, right? I'm just going to be careful. I subtracted the first function to the second function, and that's what I got. So, number 3. All right, we're basically going to multiply. Do you see FG? FG means F times G. Even though you got an invisible, I like that. You got an invisible, there's an invisible times sign. We all know that, right? So we're multiplying. So it really means, in a sense, F of G times G of X, right? F of X times G of X, we're going to multiply them. So I'm going to take my 2x minus 2 times my x squared minus 2x plus 1, right? And we're just going to multiply it out. 2x cubed minus 4x squared plus 2x, then minus 2x squared positive 4x minus 2, okay? Grand answer of a 2x cubed minus 6x squared plus 6x minus 2. Not hard. We've done all of these things before. It's just a different way of looking at the question. Same question, just written differently, okay? So what do you think about the next one? How about example 4? What's going on here? We're just going to divide. You guys agree? We're going to really take f of x and divide it by g of x, okay? It's just a different way to look at the symbolism, that's all. So I'm going to take my 2x minus 2 over my x squared minus 2x plus 1. And normally I'd be done, but let me give you an analogy. If you gave me an answer of 8/16, I'd say, come on, seriously, 8/16? Are you going to leave me that answer, or are you going to make it a 1/2, right? Agree with that? 8/16, are you serious?
That looks bigger.
Well, can we do something similar with this fraction? Sure, let's factor. I get a 2 times an x minus 1 over an x minus 1, x minus 1, right? Which is going to make cancel, right? A 2 over an x minus 1, which is a much nicer answer. I just reduced my fraction, right? We reduced it. Got a reduced fraction, right? Okay, now, question number 5. What do you think it asks us to do? Add them and then what?
Divide.
No.
Divide.
Plug into, because it's of 2. It's of 2. So what it really means is this. It means f of 2 plus g of 2. Now we've already added, haven't we? So let me go ahead and take a little trip up here. Okay, way up here. I already added the functions, right? Didn't I already add the functions? So when I added the two functions, I got x squared minus 1, right? So let's go ahead and rewrite that. So I know that f of x plus g of x was x squared minus 1, because we did that way up above, right? Now let's just plug in 2. All right, I can do that. So I'm going to go f plus g of 2 is to plug in 2 into their added answer, okay? So I added them. That's what I got. Now I'm going to plug in 2, so I'm going to go 2 squared minus 1, right, which is a 4 minus 1, which is a 3. Now, another way you could have done this is that you could have plugged in the 2 way up here, got an answer. You could have plugged the 2 up here, got an answer, and then you could have just added those 2 answers. It would have worked, okay? Return the page?
No.
All right, I'll wait for you. I'll wait for you. Thank you.
It's slow.
No, don't be, no, I tend to be fast. Oh, McKenna. And you know what, McKenna? Here you go. I'll let you borrow mine when I'm done, okay? Got it. Okay. Give me a thumbs up when you're ready.
I'm going sideways.
Okay, all right. Turn the page. All right, now, same stuff except for we've got some cube roots and cube roots. Okay, now here's where it gets hard. Okay, now, front was pretty easy, right? So let's do this. So f plus g. So we're really going to take a cube root of x plus 2 cube root of x, right? That's not hard. Okay, so I'm just going to add them. It says f plus g. So add this 4 cube roots of x plus 2 cube roots of x. Should probably make a 6 cube roots of x, right? Thumbs up? Now take f plus g of 8. So let's just plug in 8. So f plus g of 8 is the same thing as 6 times the cube root of 8. So, I already added them. I got this value, 6 cube roots of 8, right? And now it says to plug in 8 into my answer. All right. 6 times 2. Okay, you guys know where I got the 2? Cube root of 8 is 2, which is 12. Yep, nice job, Callan. All right, so what do you think about the next one? What are we going to do here?
Subtraction.
Yeah, so let's subtract them. Let's just take our 4 cube roots of x minus 2 cube roots of x. That's pretty easy, right? We're going to get 2 cube roots of x. Thumbs up on that one? Okay, that's not too bad. And now plug in negative 27, right? Oh, we can do a cube root. We can. We can. So we're going to get 2 cube root of negative 27. Now you can do a negative because you know that negative 3 times negative 3 times negative 3. I'll do it again. Negative 3 times negative 3 times negative 3 makes it negative 27, right? So this is cube root of negative 27 is just negative 3. So we get an answer of negative 6. How am I doing? All right. Example 3. All right, what do you think we're going to do? What's this? What are we going to do? Multiply. So let's take a 3x cubed and multiply it to a 6 times the cube root of x. Now when I multiply, I add exponents. Let's get an exponent. When I multiply, we're going to have to add exponents, right? All right, so I'm going to rewrite this as 3x to the third times a 6x to the 1/3. Okay, how's that? Which is going to make an 18x to the 3 1/3. Okay? Nah, that's not a very nice answer. I can fix that answer. How about 18x cubed times the cube root of x? Does that bother you?
Mildly.
Okay, which is kind of what I could have had here, huh? Right? So now, let's plug in negative 8. So I'm going to go 18 times negative 8 cubed times the cube root of negative 8. Okay, will you help me out with that? Okay, what is negative 8 cubed? It's going to be a negative 512? Is it negative 512? Negative 8 cubed? Okay, hey. Negative 512 times negative 2. Do you know where I got the negative 2 from? And so let's just do that. Callan, do you mind going that times that times that? 18 times negative. 18,432. How's that?
Big.
Remember I told you front page pretty easy, back page a little bit harder, right? But we're doing all right. Now, last problem. What do you think we're going to do? Let's just divide. So let's take our 3x cubed over 6x to the 1/3. So when we divide, we're going to subtract exponents, okay? So if I subtract exponents, I'm going to get a 1/2 x to the 2 1/3. Okay, subtract exponents, okay? Or 1/2 x squared times the cube root of x. Now that might bother you. You see the x squared, right? There's the x squared. And here's my cube root, because the 1/3 power, right? Okay, now let's plug in 64. Let's go 1/2 times 64 squared times the cube root of 64. That's 4. 64 squared, I have no clue. What is 1/2? What is 64 squared? Okay. 64 squared is a big number, I'm sure that. 4,096. 4,096 times 4. You guys okay where I got the 4?
Yeah.
2 over 64. And then I'm just going to multiply that. Times 0.5 times 4. And I got a grand answer of 8,192. Okay, and I don't think we have time to look at the journal, but that's okay. It's there for you anyway, okay? So, that's what I got for you. And I've got some